All right, part 3, number 3. A running back accelerates from 0 to 4 meters per second in 0.5 seconds. Find his acceleration, part A. Okay, so part A, find his acceleration. So what are the things that I know? I know that this problem took place in half a second, so I'm going to write that down. T equals 0.5 seconds. What else do I know? I know that the running back started out going 0 meters per second and ended up going 4 meters per second. Well, my meters per second is my units of velocity. So let's write those down. So it could either be, either number could either be my initial velocity or my final velocity. Well, my 4 meters per second is going to be my final velocity, because that's where he ended up. And my initial velocity is going to be 0 meters per second, because that's where he started. And the problem just says, find his acceleration. Okay? So we're looking for acceleration. So let's look at our formula sheet. Which one could we use? Well, this one just says A is equal to VF minus VI divided by T. So I'm going to use this formula and plug in what I know. For VF, I know it's 4 meters per second. Minus VI, that I know is 0 meters per second. Divided by T is 0.5 seconds. So when I do this out, I should get 8 meters per second squared is my answer. Okay, part B. Let's see. How far does he run in 2 seconds if he keeps up this same acceleration? Okay, so part B says, how far does he run? Well, that means we're going to be looking for distance, right? How far, or displacement. How far means we're going to be looking for distance or displacement. And then it says he does this for 2 seconds. So we know that our new T is going to be 2 seconds. And from up here, our acceleration, 8 meters per second squared. Okay. So we need to find our D. We know our T. We know an A. Do we know our initial velocity? Well, that was 0. It was given to us in the problem in part A. So he starts out at 0. So I'm going to write that down as his initial velocity. Okay. So which formula can we use? It looks like this one again. So D is equal to initial velocity times time plus 1/2 times acceleration times time squared. So that's going to be equal to this multiplies out to be 0, so I'm just going to write 0 meters here, plus, and then I have 1/2 times 8 meters per second squared times, and then I'm going to square this whole thing, so I'm going to get 4 seconds squared. So 8 times 4 is 30, what is 8 times 4? 32. Divided by 2 is 16. So my answer is going to be 16 meters.